Good morning, friends. So in the last lecture we have discussed about the object oriented programming and its concept. So we have looked about the object. So anything that has the entity, that has the identification, and that has the attributes, and that has the function, it's known as objects, right? So anything that has an identity, attribute, and behavior is termed as an object, and the objects are created from the class. Class is like a blueprint from which we create an object, okay, that we have discussed so far. And the process of creating an object from the class is known as instantiation. So we have taken the example of the bank account. So while creating the class, we will define its attribute, we will define the name is bank account, and we have defined the methods like to open a bank account, to close a bank account, like that. So we have a name, attributes, and behavior, and then from this class we are creating the objects, which is known as instantiation. And then we have a different objects from the same class. Like from the blueprint we can create as many houses that we want. Same way, with the help of one class we will create as many objects we want. So now while creating the classes, we have to keep in mind the few principles of object oriented programming. So today, in today's lecture, we are going to see those four principles in details, and these four principles are known as abstraction, polymorphism, inheritance, and encapsulation. So these are the very important terms, and as an IT consultant or as an programmer, you should be aware what these terms mean actually. Abstraction, polymorphism, inheritance, and encapsulation. So the short trick to learn this is a pi. A for abstraction, P as a polymorphism, I as an inheritance, and E as an encapsulation. So today we are going to see all these four details. So let's start with abstraction. So what is abstraction? So when I say abstraction, I mean focusing always just on essentials. Okay, so this is the meaning of abstraction. Focusing always just on essentials. So if I say table, you know what I mean. Okay, when I say a table, so you know what I mean. I didn't say I was thinking of a wooden table or a glass top table, if it has a 4 legs or it is a central pillar, if it is a large table or small. No, I said nothing like that. I just said table, and you get an idea of the table, what the table looks like. Yeah, every table might be a different. You must be thinking of the wooden table, I must be thinking of the central table, you must be thinking of a dining table. That's all, that's fine. But you get an idea that okay, we are talking about the table, right? You might have an image in the mind, that's okay, but I don't have to get that specific, because you understand the idea of the table, the abstraction of the table. So that's what called the abstraction. We are focusing just on the essentials so that you get an idea. Okay, so abstraction means we focus on essential qualities of something rather than on specific example. And abstraction means that we automatically discard what's unimportant or irrelevant. So we will, in abstraction, we will discard what's unimportant or irrelevant. Okay, so your mental model of table might have the potential height and width, but it's unlikely to have an engine size, right? So when I say a table, you will not think about the train. Okay, so train and the table are two different concepts, right? So when I say a table, you get an idea of the table. So like that. So you must have get an idea of the abstraction. So when we create a bank account class, we are not creating the separate bank account classes for every person, right? We will focus on the essential qualities of the idea, and we will write one bank account class. We will focus on things like each of these will have an account number and all those things. So when we are creating a bank account, so here when we creating the bank account, we are just focusing on account number and balance, right? So we are not creating a separate class for Joe's bank account and another class for Alice's account. We are creating the one bank account class, and from this one bank account we are creating the multiple objects for different persons, right? So it might be true that every person's bank account have different details, right? But if our application doesn't care about that piece of information, we don't need that attribute defined in our class. So in our bank account, we are just defining two attributes, account number and the balance. And for each specific person, there are more details, but we are not, focusing on those details because those details are not that much important or that are not relevant to everybody. So that's the concept of abstraction. So you have seen that abstraction is the very basic concept, and it supports other fundamental concepts of object orientation program such as inheritance and polymorphism. So this completes an abstraction focusing on just on the essentials and ignoring the unimportant. So that's abstraction. So now coming to the next feature, that is encapsulation. So what is encapsulation? Encapsulation is that you enclose. Okay. So what is an idea of the encapsulation? Idea of encapsulation is that you enclose. Okay. Let me increase the font here. So you encapsulate your object attributes and methods, and then you hide everything about that object except what is absolutely necessary to expose. Okay, so think of it like as a medical capsule. So in this medical capsule, what do you just take the medicine, right? And you are expected to be cured from the disease, but you do not know what exactly inside in that capsule. You are just taking the capsule, but you are not aware of what's in the capsule. Okay, so that's an idea of encapsulation. That is the idea of the surrounding something, not just to keep the contents together, but also to protect those contents. Okay, so it's just not the hiding concept, it's also to protect those contents. Now in object orientation, this refers to the idea of taking our attributes and then taking our behaviors and building them together in the same unit. So if in the above examples, what we have done, we have this bank account class, we have this account number. So if I say this diagram, okay, so we have these attributes, okay, and then we have these methods, and we are bundling them together. This is an encapsulation. You know, you have the data and you have the method or behavior, and you are encapsulating it like a capsule. Okay, so this is known as data hiding also. So this encapsulation, like a medical capsule, provides the feature of data hiding. Okay, data hiding. So we have the access modifiers, like you have heard it, private, public, and protected. So in Java we have this access modifier. So if you want to keep your data private so that no class outside of this particular class can't access your data, you define the data as a private, or if you want to give the access to that data, you define the data as a public. So like that. So this is the encapsulation. We have the data hiding feature available to us. The principle is that an object should not reveal anything about itself except what is absolutely necessary for other parts of the application to work. Okay, it's like a black box. So you in this interface, you are just given these two holes where you can plug in, and then this black box will do its phone. It's like a telephone. When you have a telephone, you just dial your numbers, right? And you can communicate to the other end of the person. You don't have to worry about what the complexity of the telephone, how the workings of the telephone, right? So we can hide that attribute. So let's take the example of this bank account class. Okay, so now this is the bank account. We have the account number, we have the balance. Okay, so you do not want that any other class will change the balance of your account, right? There is a security feature involved in the real world programming, right? If we have this bank account class, we don't want some other part of our application to be able to reach in and change the balance of any object without going through the deposit or the withdrawal behaviors, right? So if anyone wants to change the balance, for changing the balance, we have to go through the deposit or withdraw method. Okay, that is defined inside the class. So in this case, the balance is only provided to the deposit and the withdraw method. Any function or anyone outside this class doesn't have access to this balance. Only these two functions can access the balance, and in these functions you have your application specific logic. Perhaps those behaviors are supposed to perform an auditing and logging of deposits and withdrawals, right? So you can perform those logging features inside this function. So this is the idea of the encapsulation, that is, you are hiding that attribute, that piece of the data. We can control access to it so that it's only accessible from inside that object itself. Okay, sure, we can use the deposit and withdrawal methods from other parts of the application and they can change the balance, but it can't be directly changed from outside the object, right? So we can change the balance by using these withdraw and deposit methods, but we can't change the balance outside this class. We have to use the class behavior to change the balance, and then in that behavior or in that method you have the application specific logic, right? So it's like we are closing off more and more of the inner workings of the object, except for those few pieces we decide to make public for, say, input and output. It's like just like the black box, just you have the two things, input and output, and other things are like you're not aware of what inside. You just have the input and output and the workings are aware of you. Think of it like a telephone. You want your interaction with the telephone to be as simple as possible, right? So just use the keypad to make a call, but you don't want to care about how it works internally, right? So you may ask that we are writing the class, then why you want to hide the data, right? So you are writing the class for your application, so why you want to hide the class's data from outside world? So it's not about being secretive. Okay, that's not the point. It's about reducing the dependencies between different parts of the application. Okay, so reducing dependencies between different parts of an application. Okay, so to explain this point, so let me give you an example. Okay, here, so we have the bank account. Okay, and in this, suppose you started off this balance attribute as a floating point number. Okay, so you defined this balance as a floating point integer. Okay, now later on you decided to convert into the balance as a, you decided that it's much better to store it as a two integers, one for dollars and one for cents. So later on you change this balance to dollars and cents. Okay, so you have two attributes in spite of one single attribute for balance. You have the one attribute for dollars and one for cents. Previously it was floating point, right? So in this case, when there is a change, you do not have to worry about the different 17 parts of the application where you are using this. You just have to worry about this class. So once you change this bank account class, you do not have to worry about the different 17 or 20 parts where this part is being used. You just have to worry about this class. So the whole idea of the encapsulation is to reduce the dependencies between different parts of the application plus the security. Okay, yeah, the security feature is also there. So you do not want your bank account balance to be changed by anyone or everyone. You want that only my balance should be changed only through the methods inside from my class. So we have the security features, and also we are reducing the dependencies between the different parts of an application. So this is achieved through encapsulation, right? So you get the idea of the encapsulation, right? So to summarize, the encapsulation is that you encapsulate your objects, attributes and methods and bundle them inside a class so that you can get an security feature, and also you are reducing the dependencies between the different parts of an application. So this is the encapsulation. So the next idea is inheritance. Okay, inheritance. So what is inheritance? So you can think of inheritance as a feature of the code reuse. Okay, so let me increase the font. Code reuse. Okay, so inheritance is used for code reuse. So in object oriented programming, we can create a new class. Okay, but instead of writing it from scratch, we can base it on the existing class. Okay, so we can create new class, but instead of writing it from scratch, okay, we can base it on existing class, and this is known as inheritance. Okay, we can create a new class, but instead of writing it from scratch, we can base it on existing class. So let's take an example of inheritance. So suppose you are creating the person class, right? And while creating the person class, you will define a few attributes like name and address and phone number, and perhaps some simple behavior in it. Okay, so name, email, phone, and then you have the change email behavior. So this is your person class, right? And then later you figure out that your application will need another class, and this class is known as customer, right? So now you need to create a new class customer, and this customer will have everything that has the person class, but it will also have the customer numbers, right? So you are not going to add a new attribute here, the customer number, because we are following the idea of the abstraction, right? What does abstraction say? While creating a class, you only focus on the essentials. So not every person will be your customer, right? So you will have every person will not be your customer, so you will not include the customer number in the person class. Okay, so you will not include customer number in person class, right? That is true, because every person is not your customer, so you have to create a new class. So okay, so we are creating this customer class, but while creating the customer class, you do not have to write everything again, because you notice that the customer needs everything that a person has, but it needs one more thing like a customer number. So you will create a customer class and you will inherit the other properties from the person class, right? Okay, so the phrase we use is customer inherits from the person. Okay, so the customer inherits from the person. Because you're trying to use the abstraction here, we are not going to use the customer number as an attribute in the person class. Instead, we are creating a new class, a new subclass which inherits from the parent class or a superclass called person. So just we say in our custom class what we want to add it. In this case, we would only add a customer number in our subclass. So this customer class will only have the customer number, and everything else this customer class is inheriting from the person. And this person class is superclass or the parent class, and this new class known as customer is our subclass or a child class. Okay, so same way going forward, you need someone in your you need employee in your application. So you again notice that every person is not the employee, so you will not define the employee number in the person class here. Okay, so you create a new class employee, and you just have to define the employee number and its salary, like that, those attributes in this new class, and rest all like name, email, phone, those attributes and those behavior will be in the person class. So the employee is also inheriting from the same superclass known as person, right? So now we have three classes. One is person class, okay, one is customer class, and one is employee class. These are separate classes, and the terminology that we use is the customer inherits from the person, the employee inheritance from the person, and the person is our superclass, and the customer and employee both are subclasses. So now when we are creating objects, we could choose to make person object or a customer object or employee object. And the great thing is, if I make change in the person class, it will automatically filter down and affect the two subclasses. So if I make some changes in the person class, you do not have to make a change in the customer or employee. No, it will automatically be affected in the subclasses. So this is the inheritance from you, where you can reuse your code. So while creating the class, you notice that some of the features are already available in one of the classes, so you can inherit from that class. So you do not have to write that code, or you do not have to specify those attributes. You just inherit from that class, and this is known as inheritance. So from till now, we studied about the abstraction, that is focusing on the essentials, ignore the irrelevant and ignore the unimportant. You only define what we need. So this concept we use in inheritance also. We do not define the customer number and the employee number in the person class because of the abstraction feature. We defined the new class, but the inheritance feature says that you can inherit from the person class. So this is inheritance. We also looked upon the encapsulation, the hiding the inner workings of the class and providing the security feature, and also reducing the dependency of your classes on the other classes and objects. So this will complete the inheritance. Now let's see the polymorphism. This is the last concept in object oriented design. So what is it? So polymorphism is derived from inheritance. Okay, so one of the best things about inheritance is not just the time you save in being able to reuse the code, but it's what allows us to use the last of the 4 key terms, polymorphism. So inheritance is responsible for polymorphism, which means many forms. So polymorphism means many forms. Okay, it's the most complex out of the 4 features, but once you get to use it, it will be, it has the great advantages. So here's an example. So you have this plus, this operator, right? So what does this mean? So if I do like this, a plus b, okay, so you have the a plus b. So what does it do? In lot of language, it depends. If we are adding 2 variables together with the plus sign, and if these variables are integers, it will numerically add them. Okay, so if a is 3 and b is 5, so it will automatically give you 8, right? Right, so in this case, it will give you 8. But if the 3 is, suppose, string, like Saurabh, and then b is like Garg, then it will give you a concatenated string, right? Right. So it will do the correct behavior, but a different behavior when what we have given it could have one of the different forms, right? So based on the input data, the plus operator changes its behavior, right? So this is known as many forms. So we have the same operator plus, but when the value of a and b are the integers, it does the mathematics and it does the addition for you. But when the a and b are the strings, it does the concatenation for you. So this concept is known as polymorphism, the many forms. So this particular example that I used of the plus sign is built into a lot of language, right? It's built in, it's available in C++ and it's in Java. But now we can use the same idea of this in our own classes and our own objects. So here is an example. So how can we use this idea in our term? So suppose we have the bank account class, the same bank account. So here we have the bank account, you have the attributes account name, balance, and then you have the behavior to deposit into this account and to withdraw from your account. So now you have a different type of accounts, right? We have a checking account, we have a saving accounts, and we have an investment account. So because of the idea of the abstraction, you are not creating the, checking account feature or a saving account feature or an investment account feature into this bank account feature, right? So you will create a separate class for each of them. So you have the one bank account as a parent class, and then you have a checking account, you have a saving account, and you have an investment account, and these classes are subclasses. So these classes are inheriting from the bank account. It will have all the details of the bank account, but plus all the details that are relevant for the particular class, right? So this checking account, this saving account, this investment account, all these classes will have an account name, they will have a balance, they can withdraw and they can deposit, and they do not have to define this attribute and behavior in the below 3 classes. They are already inheriting from the above classes, but now things will get more complex. Okay, it gets tricky here. So suppose when you withdraw from a checking account or from an investment account, you have to deposit some interest. Okay, you have to pay some interest. So the withdrawal method is different for the investment account from the checking account, right? So you have a business rule that says, okay, if you withdraw from an investment account without giving a 30-day notice, you have to pay some interest, right? So this withdraw method here in the investment account, okay, it should have a different behavior from this withdraw method. So you can simply, override this behavior, withdraw behavior here in the investment account and write its own logic. You are already inheriting this withdraw behavior from the bank account, right? But you can always, override that behavior. So this is known as overriding. This feature is available in the polymorphism, right? So same way, so do you get an idea that, yeah, so using an inheritance, we have these three classes, and this we have the main parent class, and we have everything available from the parent class to these child classes. But now if you want to override some of the behavior, right? So another example is like you have a car, okay? So in the car example I can take, we have a simple car. So this is our parent class, okay, right? And now you can inherit Ferrari car or BMW car, right, from this parent class. These are like, suppose, subclass. So this class will have its own speed method, and it will have the run behavior, okay? So now this Ferrari or BMW will have the run method differently, right? You can override that method. You can override the run method of the class, because a normal car might run at the 40 or 100 kilometers per hour or 100 miles per hour, but it's not true for your Ferrari, right? It's not true for your BMW. So you can override that method. So this is the concept of polymorphism. You can override the behavior what's available in your parent class, okay? So if you are, what advantage that polymorphism do is that it gives you another feature known as overloading, okay? What is overloading is that in a class you can define a different methods but with the same name, okay, with the same name. So you have a println method with the same name but with a different argument. So one println method is taking a string as an input, okay, another println method is taking integer as an input. So you are creating the API for println. So you define the 5 methods which will take the 5 different input parameters, but the name is same, println, okay? And now when the actual developer is going to use your API println, he has to remember the println only. He will not worry about, okay, we have a separate methods for printing strings or integer or long or float, okay? He just have to write the println and pass anything and it will do the printing. So this is known as overloading. So that way the polymorphism gives you more flexibility while writing the API. The job of this method is to print something, add a value, add a new line. So now you can print any kind of the data without worrying anything about it, okay? So you have this overloading feature. So this completes the polymorphism, that is many forms. So we have covered everything about the OOPS features. So to summarize, you can remember these terms as an API, abstraction, polymorphism, inheritance, and encapsulation. So abstraction means focusing always just on the essentials. So ignore the irrelevant. So while defining the bank account, you're just focusing on what's essential, okay? So this is abstraction. And in the encapsulation, we have the feature of the data hiding, like the black box. You're just giving the holes for input and output, and you are hiding the inner workings of the class from the outside world. So it will give you the security, and plus it also reducing the dependencies between the different parts of an application. So that was an encapsulation for you. And then the inheritance, it was for code reuse. And then we can create a new class, but instead of writing it from scratch, we can base it on existing class. The parent class is known as superclass, and the class that is inheriting from the above class is known as subclass or the child class. And because of the inheritance, we have the last feature available to us, which is known as polymorphism, that is known as many forms. So it gives you two features, overriding and the overloading. So in the overriding, I explained that while creating your new child class, you can override some of the methods available in the parent class, that is overriding. And I already explained the overloading, that in the same class you can define the different methods but with the same name but with a different argument, so that it gives you more flexibility to your developers. So that's all from my side for today. We have completed the object-oriented programming concepts, and please let me know if you have any questions or suggestions. Please do not hesitate to email me at kirksaurabh786@gmail.com, and please do comment if you like the video. Thanks for watching the video, and I'm very grateful to you. Stay in peace. God bless you. Namaste.